Hi everyone, welcome to this breakout session on Solutions to Quench the World's Thirst, Solving Water Scarcity. I'm Professor Hao Yong Ng, the Director of the National University of Singapore Environmental Research Institute. I'm the moderator and also one of the three panelists for this session. Let me first introduce the three panelists. The first panelist is Dr. Cecilia Totahara. Dr. Totahara is a Senior Research Fellow at the Institute of Water Policy, Lee Kuan Yew School of Public Policy of the National University of Singapore. The main focus of her work is on global change and impacts on water, food, and environmental security. She has authored and served as editor of more than 40 books by major international publishers, which have been translated into many different languages. She's also advisor to major international institutions such as FAO, UNDP, JICA, ADB, OECD, IDRC, and GIZ, and has worked in many countries in Africa, Asia, North and South America, and Europe on water and natural resources and environmental-related policies, management, development, and governance. She's a member of the OECD Initiative in Water Governance. Cecilia was a recipient of the Crystal Drop Award by the International Water Resources Association. She was a past president and honorary member of the International Water Resources Association. She is the editor-in-chief of the International Journal of Water Resources Development and an associate editor of Water International. Given her extensive experience and credential in the field of water and environmental-related policies, it gives me great pleasure to have her share her view on policy and water resource management. The second panelist is Dr. Srivasan Raghuvan. Dr. Raghuvan is currently the head of the Climate and Water Research Cluster of the National University of Singapore Tropical Marine Science Institute, or TMSI in short. He joined the TMSI in 2008 after obtaining a Ph.D. from the University College London. His primary research is on regional climate modeling and has been the lead climate modeler for several climate change projects commissioned to TMSI. Apart from climate research, Dr. Raghuvan has also been involved in climate impact studies over Southeast Asia. He also pursues modeling initiatives on urban scales. He's active in both national, regional, and international climate research initiatives. I am very glad to have Dr. Raghuvan to share on the impact of climate change on water security and the adaptation needs. The last panelist is myself. I joined the National University of Singapore as a professor in 2004 after completing my PhD studies from the University of California, Berkeley, and postdoctoral training in Yale University. My interest is in membrane processes for water reuse and desalination. I'm currently an editor of the Journal of Water Reuse and Desalination and an associate editor of water research. I also contribute to the professional community as the vice chairman of the International Water Association Membrane Technology Specialist Group and as a president of the Environmental Engineering Society of Singapore. Without further ado, I shall pass the floor to Dr. Cecilia Totahara.
The story of independent Singapore started only 55 years ago in 1965. Since then, the city-state's apparent vulnerability due to its small size, almost total lack of natural endowments, and high water dependence on external sources has been turned into a myriad of opportunities, propelling it to higher levels of development. The characteristic, efficient, and pragmatic decision-making in which policies have been formulated and implemented have made national strategic planning a distinctive process. Forward-looking and holistic thinking have been consistently channeled towards initiating required changes and anticipating and responding to new problems and challenges in what seems to be a permanent search for feasible and cost-effective alternatives. In Singapore, overall policymaking, including the one related to water resources, has followed a think ahead, think again, and think across philosophy. Within this overall framework, policy and decision-making processes consider possible important future events as well as their impacts and implications for the city-state, or think ahead. They re-evaluate the decisions taken in the light of different scenarios and modify them accordingly in order to improve them. think again. Finally, they look for experiences and know-how worldwide to enrich the pool of knowledge, think across. This constitutes a comparative advantage for the country, as possible surprises are anticipated and factored in. Decisions are reassessed and improved according to global changes, scientific and technological developments, and to societal attitudes and perceptions. And results and a broad range of potentially relevant scenarios are evaluated. Therefore, seemingly serendipitous events are not always unexpected, and future changes and challenges are instead searched for, identified, and addressed in advance of their occurrences. The city-state continues to pursue a development path that will not undermine its scarce water resources over the long term. Following this line of thought, PUB, National Water Agency of Singapore, has identified several strategies to ensure the city-state's continued and sustained development. These strategies include improving use and management of water resources so that they are available for the increased number of users and users, enhancing the physical environment by controlling pollution, increasing green areas, and cleaning and beautifying water bodies, engaging and encouraging communities to play their part by adopting more responsible practices, habits, and lifestyles, and building technologies and capabilities with the objective to reach sustainable development targets and propel economic growth. Singapore's water story points at the importance of investing in new and innovative technologies that use and reuse all available water resources as many times as possible. It also realizes the relevance to put in place policies that encourage the use of such technological advances, including substituting potable water with other alternatives such as new water or desalinated water, as well as any other alternative when feasible. New water is very high-quality recycled municipal wastewater, mostly for industrial use, and in small percentages, also for non-direct potable use. Looking for water use efficiency, Singapore has set specific targets for domestic water consumption. Per capita household water consumption has been reduced from 165 liters per person per day in 2000 to 141 liters in 2019. The target is to reduce it to 130 liters by 2030. To expand water supplies, catchment areas have been increased to 2/3 of the island's land area. New fringe catchments are being developed. More new water is being produced and used more intensively, and more industries are being encouraged to replace potable water for non-potable purposes with new water or desalinated seawater whenever technologically and economically feasible. There have been many achievements which are unquestionably commendable and exemplary in Singapore. Nonetheless, with the resource constraints the city-state faces, it will have to run faster to keep up with developments, maintain good rates of economic growth, and, above all, respond to societal expectations. While Singapore justifiably prides itself of the enormous progress it has made over the last decades, it is also fully aware of the many challenges it faces, of the old but recurrent issues that need to be improved upon, and of the new emerging problems that ought to be addressed in a timely manner. As in the past, the motivation to continue striving for excellence and improvement will emerge from societal expectations as well as from international dynamics. At home, the objective is to give answer to the population's increasing aspirations for a better quality of life. Globally, Singapore will have to successfully navigate in an increasingly uncertain future of social, economic, environmental, and also technological conditions that will be beyond its control. However, this will be done looking ahead, looking again, and looking across.
Thank you, Dr. Cecilia Todahara. Next, I will invite Dr. Srivasan Raghuvan to speak.
Hi, I'm going to talk to you on the impacts of climate change on water scarcity and specifically water security, if you put it. And we all know that climate change is already happening. There's been a lot of news around the climate change and its impacts around the world, and especially in Southeast Asia, which is comprising of developing nations. Or most of these countries in Southeast Asia are highly climate vulnerable, which means that in the context of Southeast Asia, climate change is critical. And in terms of the impacts to agriculture, especially because most of these countries are largely based on agriculture as one of the drivers of economy, then it means that the future rainfall is uncertain. That leaves agriculture in a bit of a peril. We've seen that some of the regions already, for example, in Thailand and Vietnam, have faced a lot of reductions in the harvest and in terms of yields in crops and different crops. And it's also linked not only to changing climate, but it is also due to management practices to some extent. But the main driver is in fact climate change. What the global models, climate change models are telling us is that the future rainfall is going to be mixed trends, meaning that some regions are going to see more rainfall and some of the regions are going to see decreased rainfall in the near term, and therefore in the next 50 years, and therefore by the end of the century, these are going to get worsened. And we have different climate scenarios on which these projections are based, and therefore it tells the policymakers to be prepared, there's always a measure of uncertainty in telling how much is the rainfall going to be different, but then there are some indications, possibilities or probabilities. The climate scientists put and say this is going to be sort of a decrease and an increase, which we have to be prepared for. We have been seeing these kind of reductions. So we know that Vietnam is facing reduction in yields, and so does Thailand. And there's a lot of issues in terms of hydrological management in Laos, because they have a lot of hydropower, and so in Myanmar. But not only on this, the side of hydropower, they are also agricultural countries. The rice belts sort of, and they have Laos has a lot of sugarcane and so forth, which require a lot of water. So water problem is going to be severe in the years to come, which means that we have to start planning for some water management issues. I mean, that's more a policy decision. There's more to do with adaptation. But nevertheless, when we look at the sky for rain, especially for rain for agriculture, it's going to be critical. And that leaves the question that if the crops are really based on rainfall, and there's going to be a lot of disruptions to yield and harvest, and then disruption of supply chain in Southeast Asia, then the food prices are going to go up. So this all says that water scarcity is an issue that we have to be dealing with, and which means that there are already some studies going on to say the water table is decreasing, the groundwater table is decreasing, and with more population, we're going to see that the per capita water use is going to be limited, and therefore the water scarcity will be a problem, not only for drinking, safe drinking water, but also for agriculture. So in terms of climate change, droughts are going to happen, and they're going to be for extended periods. Floods are also critical to climate change, but it's relatively short term in terms of the rainfall, and then the post-flood is as a management issue. But drought can be severe, and the severity of drought is linked to all these supply chains and driving the economy or whatever. So we have to be equally concerned about drought in Southeast Asia, which does happen a lot in Indonesia, sometimes in Vietnam. We have seen problems in Thailand, and it's going to be worsened in the years to come. That's what the models say. For example, the Java Island in the future is going to get drier, but we know Java Island is also seeing a lot of floods, but that is an extreme event. But the total annual rainfall in the future is going to be declining, and that's what the models tell us. So as much as we would have floods as an extreme, we would also have extreme droughts. And that tells us that it's rather an alarm or an alerting bell to say that we are going to be facing water problems in the future. And added to the population growth and sort of when we have problems on management issues, then this is going to be a problem which we have to seriously face. So let's see how climate change is going to keep us going. And we have to do something about it sooner or later, more in terms of adaptation. Let's start adapting to climate and then plan for the future as we keep to the science and see what the models are telling us and how prepared are we with adaptation. Therefore, when we know that the science is telling us a better picture, then we evolve ourselves in adaptation. But the adaptation has to start now, keeping in mind sort of worst case scenario so that we are prepared for anything less than that. And so this is a serious problem, and water problem is going to be not only for Southeast Asia. Of course, we're talking about this because we are in this region, but this is applicable to any other countries, like larger regions like Africa, even Australia, which is largely drought prone and so forth. So it's time that we really look at climate change and water scarcity as a problem. There are policy dimensions also, but my focus is more on the research of climate change, climate modeling, and what these models tell us, and what can we learn about these impacts using the output of climate models. Thank you.
Thank you, Dr. Srivasan Raghuvan. Last but not least, I shall discuss about technological solution to combat physical water scarcity. Advancement and innovation in technology has been a major key to realizing the production of clean water from wastewater reclamation and seawater desalination. Out of various technological options, membrane technology has become the main technology in recycling wastewater into a renewable water source for indirect potable reuse and meeting various industry needs. It is also the primary technology used for seawater desalination. To date, innovation in technologies are being sought and applied in many different aspects across the water loop. For example, in water conservation, watershed management, smart technologies in water quality and security monitoring, network management on prediction and prevention of water pipe leakage. A prominent example of great effort in promoting water innovation is Singapore. Singapore has invested more than 700 million Singapore dollars in R&D since 2002, with the aim to solve Singapore water challenges. The R&D ranges from fundamental research to proof of concept and demonstration scale systems, which are conducted through collaborations with local and international research institutes, Institute of Higher Learnings, and companies. Global trend on water recycling and reuse has also driven towards industrial water reuse in the recent years. As we know, industrialization has brought great civilization to mankind, but unfortunately, it has also contributed to adverse environmental impacts. Our knowledge and technologies developed over the past decades for domestic wastewater are being expanded for reuse and recycling of industrial wastewater. 1/5 of the global water use is being supplied for industrial activities. For example, in Singapore, 55% of the water demand is currently from non-domestic sector. It is projected that this will increase to 60 and 70% in the next 10 and 40 years respectively. Thus, majority of water supply would be diverted to meet the industrial water needs. Such pressing issue in meeting the increasing industrial water demand is a global challenge. Management and technologies for sustainable water reuse are invested especially on reducing the industrial water demand pressure. This in turn would free up more water for other usages such as drinking and agriculture. Strategies in industrial water demand management could include modification in industrial processes, conservation and reuse of water within the process. This concurrently would reduce generation of wastewater for treatment and recycling. In addition, novel technology that is technical and cost efficient should be further developed to remove complex organic present in industrial wastewater. Examples of novel technologies include granular activated sludge process, moving bed membrane bioreactor, photocatalytic process, and electrocoagulation process. Some researchers even explore specialist organisms such as marine algae for degradation of recalcitrant pollutants in high saline wastewater. Zero liquid discharge approach may be required for industries deemed hazardous to safeguard the environment. Improvement in conventional membrane processes for water reuse and seawater desalination by developing novel membranes with higher permeability, selective permeation, and high fouling resistance is important moving forward. New membrane processes and application of electromembrane process such as electrodialysis reversal and capacitive deionization could enhance water recovery rate at lower operating cost. Direction of technology innovations will need to evolve with the increasing pressure on water security caused by climate change. Different stakeholders will need to rethink on solutions, not only to produce water to meet the demand, but to provide sustainable water that are resilient to climate change. Innovative technology will need to be more environmental friendly by being more energy efficient and producing less byproducts that are harmful to the environment. In summary, management and technology should strive to achieve an overall balance to address water challenges under the climate change era. With this, thank you very much for your attention, and we look forward to the discussion in this session.